Hi, my name is Blaise Haviland, and today we're going to work through some examples of nomenclature. In the first example, we have sodium chloride. What you first want to do is identify the elements and its charge based on where it is on the periodic table. We know sodium is in group 1A, will have a +1 charge, and chlorine is in group 7A, which will have a +1 charge, or -1 charge, excuse me. So then what you need to do to bring them together is use their charge as the subscript of the opposite elements, and we can see that they're both 1, they'll cancel out, and sodium chloride is NaCl. In our next example, we have CS2S, and I'll write this out so you can see it. We know cesium is in group 1A, and sulfur is in group 6A, and we'll have a -2. And this is where you can see the 2 became the subscript for the cesium, and we don't write 1s. So to name this, we see that we have a main group metal and a non-metal. When naming these, you want to write the name of the metal and with no change, and then the non-metal with the ending "ide." So we have cesium sulfide. In our next example, we have ammonium phosphate. We can see that this is going to be a polyatomic ion, they each are. And so for ammonium, we have NH4 + 1, and phosphate PO4 - 3. So we're going to do the same thing when we're working with these ions and use the charge as the subscript. And when you're working with polyatomic ions, if you're going to have a subscript outside of the polyatomic ion, you want to put it in brackets. And again, we don't write 1s, so there's no need for that. So then we'll come over here. We have NH42 SO4. Same thing, so we'll write this out. NH4 we know is +1. And we know, even if we don't know the charge on sulfate, we can see that it took 2 NH4s to bond, so we know that it's SO4 - 2. So to name this one, for polyatomic ions, you're just going to list the 2 polyatomic ions, just like here, ammonium phosphate, so it's going to be ammonium sulfate. In our next example, we have chromium-3 iodide. When working with transition metals, you want to look at the Roman numeral after the element to determine the charge. So we know that it's Cr + 3, because we have 3 here. And we know iodine is in group 7A, so it's a -1. And again, we'll just cross multiply, and that will give us CrI3. In our next example, we have VO2. We know this is vanadium, and we don't know the Roman numeral yet, so we will leave that. And then we have O2. We know oxygen is in group 6A, and it has a -2, and then we have 2 oxygens. So we're going to have a total of a -4. So I'll just write O2 -4. And we don't have any subscript for vanadium, so we know there's only 1. And because it is a neutral compound, we know that vanadium is going to be +4, and that will give us vanadium, and it's a transition metal, so we have to write the Roman numeral. And then the same naming rules apply. We're going to add the I to the end of the oxygen. In our next example, we have phosphorus tribromide. We can see that this is a covalent bond because of phosphorus and bromide being on the right side of the periodic table. So what you need to do is write the element, and the way to tell the subscript for covalent bonds is based on the prefix. So we don't have anything for phosphorus, and that means it's 1 because we don't write mono at the beginning. And then for bromine, we have tri, so we know that means 3. So we know that our phosphorus tribromide is PBr3. And lastly, we have H2O. If you identified this as water, good job. But that's not what we call it here. So what we need to do is, we see that we have 2 hydrogens and 1 oxygen. Again, this is going to be a covalent bond. And so what we need to do is we have hydrogen, but because there are two of them, we have to add the prefix, so it's going to be dihydrogen. And when we have only one oxygen, it will be monoxide.